Hello friends, this video on polymers part 9 is brought to you by examfear.com. No more fear from exam. Now we discussed about the chain growth and the step growth polymerization reaction. Let's see some of the examples. For chain growth polymerization reaction, we'll see the preparation of polythene, high density, low density, Teflon, Acronitrile, polypropylene, polystyrene, PVC, butadiene S, neoprene, polyvinyl acetate. All these, let's see the preparation of these because they are important polymers. And these polymers are formed by chain growth reaction. We'll also see some list of polymers that are formed by the step growth polymerization reaction. We'll see the preparation of those as well. Right? We'll start with the polythene, the low density polythene. So polythene, we have told you that this is, in fact, polythene if you see is used here, the poly bags. And this is also polythene. Okay. So how do you get polythene? Polymerization of ethene. Polymerization of ethene right here. Polymerization of ethene under high pressure, and that's why I'm talking about low density. Low density is under high pressure, very high pressure, almost 1000 to 2000 atmospheric pressure, and temperature is 350 to 570 Kelvin, this kind of temperature, and plus some oxygen, trace of oxygen. And obviously, since I told that this is all chain growth, so it needs some catalyst to initiate the reaction and to form the active ethene here. And for that, we'll use peroxide. We can use any peroxide. We can use benzoyl peroxide to act as catalyst. So we'll talk about the reaction mechanism. In fact, we have talked about this. We have benzoyl peroxide. In this benzoyl peroxide, what happens is it breaks. It forms two of these CO2. And from this, actually this bond breaks and carbon dioxide comes out to get 2C6H5. This again reacts with ethene to form C6H5, CH2, CH2. This is active. This is my chain initiation step. Once I have got this, so these reacts with n number of different molecules. So from C6H5, CH2, CH12 traces to understand that this is something which has got extra added. Again, this will react with more ethene. Reaction will continue, a lot of things will be added and form C6H5, CH2, CH2, n number of these, CH2, CH2. That is chain growth state. And then will be a chain termination step where this will react with one more of similar kind of this liquid. And let's assume that this is M. This is N, this is M. CH2, CH2. And then form a final product. Right? The final product will be C6H5, CH2, CH2. Some chain molecules of this, CH2, C6H5. Right? And here K is nothing but N plus M plus A2. Right here, N plus confused. This is the polythene molecule which you get. Okay, so this low density polythene is chemically inert, and this is tough but flexible also, poor conductor of electricity. Also used for insulating electric wires. It is used to make squeeze bottle, toys, flexible pipes, this kind of thing. So in this toothpaste, this is the polythene. Okay. High density polythenes, So if you talk about high density, the density is high and it is pretty hard. For example, this is high density, this is high density, this is high density, this is low density, this is soft, these are hard, right? This again high density polythene, I'm talking about high density polythene itself. So in high density polythene, the polymerization takes place in the presence of again a catalyst such as triethyl aluminum. Okay, and this take place in some hydrocarbon solvent also. This is the solvent, this is the catalyst. Okay, temperature is almost similar, little lower only 333 to 343 K, and the pressure is also low, 6 to 7 atmosphere. So in the case of low density ethene, polythene, we saw that the pressure was very high, 1000 to 2000 atmosphere, but in this case the pressure is low. And the density is high because of close packing. But apart from that, the properties are almost same. The low density polythene, the high density polythene, both are non-conductor of heat and electricity, both are chemically inert. But since this is the closed pack, density is high, so this is a little harder and tougher. Used to make buckets, dustbins, the bottle caps, typically the pipes, lot of things is used, hard plastic. Okay. The next is Teflon. Teflon is, you must have seen the utensils in the house, it has Teflon coating. The car has the Teflon coating to prevent it from minor scratch. There are a lot of application of Teflon. In fact, the oil seals, the gaskets, these are gaskets to connect to different pipes. This is used, this is oil seals. A lot of places we use Teflon. In Teflon, in fact, the word came from this actual polymer is polytetrafluoroethene. So Teflon word came, Te came from this, Fl from this, O from this, fluoro, and ethene. This became Teflon. And this is manufactured by heating tetrafluoroethane. Tetrafluoroethane, that is CF2, double bond CF2. This tetrafluoroethane, when you heat this in the presence of catalyst at high pressure, you get Teflon. Reaction is similar to the polythene reaction. Okay, these are also chemically inert, and that's why you see it is used for coating the frying pan. If it is not chemically inert, it will not be used, it will react with our food. So if it is asked Teflon is chemically inert or not, you can just say that okay, you can think of it, Teflon is used for coating the utensils, that means it should be chemically inert. It is resistant to attack, it is resistant to corrosion and attack, that's why it is used in the utensils. Right? It is used for making oil seals, gaskets, also Teflon coated cars, bikes. Okay, but this actually Teflon undergoes decomposition. When you heat this above 300 degrees Celsius, that is something which we don't use for cooking. But if you heat this at a high temperature, it undergoes decomposition. That is Teflon. This is also prepared by the same chain growth polymerization reaction. The next is the polyacronitrile. This is also prepared by chain growth free radical reaction. Okay, so this is from acronitrile. So polymerization of acronitrile in the presence of catalyst. Again, the catalyst can be peroxide here. So acronitrile, the formula is CH2CHCN. This is acrylonitrile. So acrylonitrile in the presence of catalyst, mostly the peroxide, it will form this kind of. This is also similar to the polythene and the Teflon reaction we have seen. This is a substitute for real wool. Real wool is costly. This substitute for real wool in making commercial fibers, sweaters. So there it is used. Polyacrylonitrile. The next important polymer is polypropylene. Polypropylene is prepared by the polymerization of, again, propene. So this is from the propene. The monomer here is propene. So you see this propene here. This is propene here with propene, and propene, when it is polymerized in the presence of catalyst can be triethyl aluminum and titanium chloride, TiCl2, or triethyl aluminum, C2H53, triethyl, yeah. So this, when it polymerizes, it forms CH3 here, CH2 here, and N molecules of these, and this is polypropylene. Right? This is used for packaging film, also creating the electrical insulating coating. You see the wires that has the plastic and the polymer. Actually, this polymer is polypropylene. This non-conductor of electricity, and that's why it is used to insulate the electrical wires. The next is polystyrene. So this is again a polymer which you get from this monomer styrene. Polymerization of styrene using again benzoyl peroxide is used here because it's a chain growth polymerization reaction. So the reaction is the styrene molecule using benzoyl peroxide, N on these, yeah. This bond breaks and you get this. This is polystyrene. This is used to make combs, electrical insulators, toys, screwdrivers, handles, or any handle, plastic handles. In fact, if you see a toothbrush, the toothbrush handle is also polystyrene. It's hard. Okay. The next is polyvinyl chloride. This is typically used to make pipes. It is also used to make handbags. This is little soft, not very soft, little soft. And this is made by the polymerization of vinyl chloride. So CH2 double bonds, CL, this is vinyl chloride. If you do a polymerization of this and of these molecules, you do a polymerization instead of in presence of peroxide, by peroxide, because again the chain growth reaction, you will get something like this. This is PVC, polyvinyl chloride. Okay, this is tough and flexible. The next is BuNaS. This BuNaS was also formed the chain growth reaction. This is formed from the addition reaction of butadiene and styrene in presence of sodium as a catalyst. So this is butadiene and styrene in presence of sodium as catalyst. So let's see the reaction. Butadiene, this is butadiene, and this is styrene. Okay, this will react with sodium as catalyst, N of these butadiene, and it will form this BuNaS. So let's see how it reacts. I mean, I'll not give you the overall reaction mechanism, but just in the brief. See, there is a double bond here. This double bond, let's suppose, breaks into these free radicals, and these double bond also breaks into these free radicals. Let's assume. And these double bond also breaks into free radicals. Okay? This double bond is gone. This is single bond. This is also, let me write here. This becomes CH2. CH2. And now we have all these double bonds. Right, like this, C6H5, CH. Okay. Now, these two lone pair will form a bond. This lone pair is gone, this lone pair is gone. So, I have these many lone pairs. Now, this lone pair will react with this lone pair or form a bond with this lone pairs. So, now if you see overall reaction, this, what you get is CH2, this is a lone pair, it will form another bond. Something you don't know, CH, then double bond, then CH, then single bond CH2, then CH, and here I have C6H5, and then CH2, and this one pair will form again bond something else, and n of these will form this kind of structure. This is the mass. Automobile tires, footwears, this is resistant to abrasion. Hope you understand the overall mechanism. So these bonds will break actually and will form this kind of bond, and these two lone pairs will form again bond. These two lone pairs are remaining now. This lone pair will form bond with this, and these two lone pairs which are remaining now will actually form bond with another one. So let's see once again. So what I have done is this red color lone pairs will form bond here, these red ones. These two black lone pairs will form bond together. This is the one I have here, the black colors bonds, which you can see. And these are red color bonds. So these are the red color bonds I have. Right? So with this I think you can visualize all these reactions happening with the black color bonds, lone pair bond, the red ones. Okay. The next is neoprene. Neoprene is also called polypropylene, and this obviously is formed from a monomer called chloroprene. So prepared by the polymerization of chloroprene. So if you see the chloroprene, CH2 double bond, Cl, CH, CH2. This is chloroprene. Then you put it right here. This is chloroprene. When you polymerize this, you get polychloroprene. Okay, this bond breaks, okay, and then this bond breaks, this bond gone, this bond gone, and these two, whatever is the lone pair, it forms a double bond. That's how it works. So these two double bonds, okay. This bond breaks into these molecules, and this bond also breaks into this molecule. So I get something like this. Okay, something like this. Now these two lone pair forms a bond. Okay, these two lone pair forms a bond. This lone pair is gone. Now these lone pairs now actually combine to form chain. So one lone pair is here. Okay, polychloroprene, also called neoprene. It is non-inflammable. It is the first successful rubber substitute. That is, synthesized. First successful rubber substitute. It is even insoluble in chloroform. It has high temperature resistance and is used in conveyor belt. Conveyor belt, this rubber is used. Or this polymer is used. Okay. The next is polyvinyl acetate. As the name suggests, polyvinyl acetate, it is formed from a monomer called vinyl acetate. So vinyl acetate is CH2CH OCO CH3. This is vinyl acetate. Do a polymerization of this. You get polyvinyl acetate. Okay, this is adhesive and is used in the paints. Polyvinyl acetate. Okay. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.